Finish up with this factoring trinomials by looking at the last two examples on the sheet that I gave you, examples number 5 and number 6. So looking at example number 5, we have x squared plus 4xy minus 32y squared. And I'm hoping that somebody notices that this problem looks a little bit different than what we've seen before, in that not only do we have the variable x squared and x, but now we have this variable y squared hanging out in the back there with this y in the middle. So it's going to be pretty straightforward to take care of it. We're going to make our parentheses like we do usually with factoring trinomials. And just like we have x and x sitting in the front seat, to x times x gives us the x squared, because we do have this variable of y squared in the third term, we're going to include a y in the back seat there. Because if you remember with your multiplying using the FOIL method, when you multiply the last terms together in your binomial, y times y, that gives you the y squared in the third term of your trinomial. So we just pop the variables in there and we're set. Now we can proceed business as usual to find the coefficients that are going to go inside our factors. So to start that process, what we do is we multiply the coefficient from this first term times the multiply it by the coefficient from the last term. When we look at this x squared, we don't see a specific number there, so we know that that's that invisible implied 1. 1 times negative 32 is negative 32, so this is going to be the number we're going to be considering factors. Then we know that we're going to be looking for the combination of factors of negative 32 that add to this 4 here, the number for the middle. So I'm going to put the 4 in there. We can start. An obvious factor pair would be 1 and 32. 1 times 32 is 32, positive 32. We need a negative 32, which says that either the 1 or the 32 has to be negative. When we look at the 4 that we want these two to add to, 4 is positive. So my suggestion is, let's make the smaller of the factors negative, so that when we add, we'll get this a positive number. Maybe not the 4, but we'll get some positive number. Negative 1 plus 32 is positive 31. It's positive, but not the 4 that we want. Next factor pair, we could continue. 1, we could go to 2. We have 2 times 16. Again, 1 needs to be negative. We'll make it the smaller number. Negative 2 plus 16 is 14, not the 4 we're looking at. So we have to keep looking. 3 is not a factor of 32. If we divide 32 by 3 on the calculator, we're going to get a decimal, which says it doesn't divide evenly, not a factor. Let's go on to 4. 4 times 8 is 32. Negative 4 times 8 is the negative 32. And then negative 4 plus 8 is 4. And yay, that is the number that we want to add to the 4. So we come to our factors that we've written, and we put in the negative 4 and the plus 8. And again, as I said at the beginning of this example, we do have this y information there, but doesn't cause us any problem. It's just going to sit there. So here's our factors as they look right now. We know from previous examples that when we get to this stage, what we have to do is go back to our original trinomial and take a look at the number of the coefficient in front of this x squared. This is the number we're going to use to divide here and here. I'll write it here, but we know that when we divide anything by 1, we don't change up its value. So negative 4y divided by 1 is just the negative 4y. So dividing by 1 doesn't change our information in our factors. So our factors would stay the same. I'll write it again to make it look nice and clean. Okay, now going on to the last example, number 6 here. Let's try not to be so crooked. We have 21x squared minus 41x plus 10. So we know we're going to have our factors, and we start. 21 times 10 is 210, and we're going to need the factor pairs of 210. When we have a large number like this, it can be kind of beastly to plow through and find all the factor pairs, and sometimes that's what we have to do. It's always a good idea, though, to take a look to see if it is possible to factor out a greatest common factor from our trinomial, which would knock all these numbers down to be smaller and more manageable. So let's take a look to see if we can do that. 21, well, we can divide that by 1 and 21, 3 and 7. 41 is prime, which is the deal breaker here because we can only divide it by 1 and 41. So unfortunately, there is no greatest common factor, and we're stuck dealing with this 210 here. Now, we know the factors of 210 have to add to some specific number, and that specific number is going to be the negative 41 in front of our middle term. So let's get started with our factor pairs. I mean, I could start with 1 and 210, but I'm hoping you'll see that's no way we're going to get close to 41 out of that. So I'm going to start with 2 and 105. 2 times 105 is our 210, our positive 210. And when we look here, we see these two factors need to add to a negative number, which says that these both need to be negative. A negative times a negative is the positive that we need. And now negative 2 plus negative 105 is negative 107. It is a negative number, not the one we need, and pretty far away from the negative 41 we need. So let's continue on. 2, let's try 3. 3 times 70 is 210, so negative 3 times negative 70 would give us the positive 210. And then negative 3 plus negative 70 gives us negative 73. Not what we need. We have to keep going. 4. 4 is not a factor of 210. You try to divide 210 by 4 in the calculator, you get a decimal number, not a factor. How about 5? We can use 5 and 42. Negative 5 times negative 42 is our 210, and negative 5 plus negative 42 is negative 47. Getting pretty close to where we need to be. Not quite there, but we're getting closer. 3, 4 doesn't work, 5, 6. So divide 210 by 6, and you find that it is a factor with 35. So negative 6 times negative 35 gives us our 210, and negative 6 plus negative 35, eureka, we finally get that negative 41 that we've been looking for. So we come here, we have our x minus 6. We have our x minus 35. I've taken the 2 and put them right into our parentheses. We know we're not done. If we take a look at this, x times x, x squared, we have 21x squared, so we have more work to do here. So what we have to do is we take the coefficient, we take this number, and we divide the back seats of both of our the information in our factors. We know whenever we have fractions, we need to simplify them. We need to make them look as pretty as possible, make the numbers as small as possible. So we have x. 6 and 21, they have a common factor of 3. They can both be divided by 3. So negative 6 divided by 3 is 2. 21 divided by 3 is 7. Coming over here, 35 and 21. What number can both of these be divided by? 7. Negative 35 divided by 7 is negative 5. 21 divided by 7 is 3. So we have managed to clean up our factors. We've reduced the fractions, but we haven't been able to eliminate the fractions. We still have these fractions in them. So to finally clean this up, this 7 gets moved in front of the x, and this 3 gets moved in front of the x. Whoops. I have 7x minus 2 here, and 3x minus 5 here. Notice I moved the 3 in front of the x, but it's still inside the parentheses. It's in front of the x, but inside the parentheses. And over here, the 7, again, it's moved up in front of the x, inside the parentheses. So 7x minus 2, 3x minus 5 would be our final answer.